In an earlier module, I explained the relationship between AI and ML. As many of you know, AI has been around a long time. Surprisingly, so has ML. In this video, I will talk about why, despite the fact that ML has been around a long time, the revolution is only starting now. Machine learning has been around since the 1970s, when it was used in fields such as astronomy. It's very hard to manually examine every speck of light in the sky, so astronomers used machine learning. To apply ML in the past to astronomy, you needed experts in image processing, such as those working at JPL, a subdivision of NASA. A long time to develop algorithms to find, say, comets, expensive, powerful computers for the time, and expensive telescopes to collect data. Much of the hype around ML now is because the barriers to entry have fallen. You don't need to be an astrophysicist to do machine learning. This is because of the convergence of a number of factors: the increasing availability of data, the increasing maturity and sophistication of ML algorithms, and the increasing power and availability of computing hardware and software. Let me show you an example. Imagine you want to build that ML model to identify diseased leaves. Remember, we can do that using a standard algorithm for image classification. You don't need a PhD in image processing. Later on in this course, you will even train an image classification model yourself. But back to our ML model. Another critical ingredient for ML is data. You need to collect lots of images of leaves. Today, you can do that easily with the camera on your phone. Finally, we need the hardware and software to make that happen. That's now easier than ever before. We can use the cloud to power our ML model so that we can do it cost-effectively. Next, we'll discuss the details of why that's possible today. Earlier, I mentioned that when you have more examples, generally your ML model is better. Take a look at this graph. It shows that our loss or error decreases as we have more data. But take a closer look. Check out the x-axis. The ML error rates decrease linearly as the amount of data doubles. That's an exponential increase in the amount of data needed. Luckily, a couple of trends have helped increase the amount of data available. From about 2000 to 2007, several social and technological changes related to the availability of data occurred. Why does that matter for ML? The availability of data matters because ML learns through examples. A model with more examples will be more successful. So what happened? The cost of sending data over the internet in the US dropped from $1,200 per megabit per second in 1998 to $75 in 2005. That's a 94% decrease. As a result, broadband became common in households. More and more people have access to the internet, and the speeds are faster. During the same period, the cost of storage also fell significantly. Not just for disk storage, which is the sort of storage necessary for retrieving archived information, but also for RAM memory, which is the sort of storage necessary for big and fast applications. In 2005, the cost of 1 gigabyte of disk storage was 0.2% of what it was 10 years earlier, and the cost of RAM was less than 0.1% of what it was 10 years earlier. Then, in 2007, the iPhone launched, bringing the desktop web to phones. Users started consuming and generating data constantly.